Welcome to The Explainer. Today, we are diving into a really powerful theory that tries to connect the dots between the simplest living things and our own complex minds. It's an incredible journey from basic adaptation all the way up to consciousness, and it's all built on a single physical idea. All right, so let's start with a question that feels a bit like a riddle. You've got a yeast cell that's figuring out how to eat sugar, a slime mold which has no brain at all solving a maze, and then you have the human brain thinking about its own existence. I mean, on the surface, they seem completely different, right? But what if they aren't? What if they're all just different points on one single continuous spectrum? That's the big idea we're going to unpack.
But to really answer that question, first we have to understand a massive roadblock in science today. The source material calls it the fragmentation problem. Just think about it for a second. We've got scientists studying memory over here, and cognition over there, and consciousness way off in its own corner, almost as if they're totally separate things. And this creates these huge gaps in our knowledge. Like, how does a simple chemical reaction in a neuron somehow lead to a feeling of joy? Or how does a cell's problem solving relate to a person playing chess? We're missing the single story that connects them all.
And this slide really shows you just how fragmented we are. You've got physiology, neuroscience, psychology, even AI and philosophy. Every single one of these fields is grabbing its own little piece of the mind puzzle. But there's no unified framework, no shared language that lets them all talk to each other and build one coherent picture. So the theory we're looking at proposes this really elegant solution to that fragmentation, and it's grounded in a single physical principle that applies to pretty much all living things. Okay, first, let's nail down a key term: constraint. Now, this isn't a negative thing. A constraint is just any physical thing that guides a process, that narrows down the possibilities. So think about the shape of an enzyme. It constrains a chemical reaction to go down one specific path. Or, a riverbank constrains the water to flow in a certain direction. It's all about shaping what can happen next. And this is where it gets really cool. What happens when these constraints start working together to maintain each other? Well, you get something called constraint closure. The best way to picture this is a whirlpool. The flow of the water creates the vortex, right? But the vortex, that shape, then constrains the water to keep it spinning. It's a pattern that maintains itself. And that is the very essence of a living thing. So here's the crucial takeaway from that. You are not the specific atoms in your body. Most of that stuff gets replaced all the time. Your identity, your self, isn't the material you're made of. It's the pattern of organization that constantly rebuilds and sustains itself. The real power is in the whirlpool's shape, not in the water that happens to be passing through it at any given moment. Okay, so let's climb up to the first rung of this ladder and see how this idea gives us a totally new way to think about memory and even basic intelligence. With this new perspective, memory isn't some file you pull from a cabinet in your brain. It's a real physical change to your system's organization. When you learn something, you are literally reshaping the network of constraints in your body. So memory isn't something a system has, it's what the system is. It's the embodied history of everything it's ever done. This slide really just nails the shift in thinking. We're moving away from that old computer metaphor, memory as data retrieval, to something much more organic. It's like a path getting worn into a landscape. The more it's used, the deeper it gets, and the more likely you are to follow that same path next time, because the landscape itself has physically changed. And if memory is about physical structure, well, then it can be stored in all sorts of places, not just between neurons. We're talking about things like epigenetic marks on DNA, the way our tissues are built, even the bioelectric fields that help shape our bodies. All of these can hold memory. I mean, get this, the planarian worm. This thing is absolutely incredible. You can literally chop its head off and it will grow a new one. How? Because the memory of what it's supposed to look like isn't just in a brain. It's distributed across the entire organism, encoded in the physical constraints of its body. So if memory is that whole collection of worn-in paths, all those stored constraints, then what's cognition? Well, it's simply the ability to flexibly use those paths to deal with a changing world in real time. It's about picking the right path for whatever situation you're in right now. And you want to see this in action? Look no further than the slime mold. This thing is one giant cell. No brain, no neurons, nothing. And yet, it can solve a maze to find food. It does this by physically changing its own body, strengthening the tunnels that lead to food, and letting the dead ends wither away. It's using its own body as a memory to solve a problem. That's cognition right there. All right, now for the very top of the ladder. This is the big one.
How does this whole framework explain that seemingly magical jump from a slime world in a maze to the rich, subjective, inner world of being you?
Well, the theory says it's not magic at all. It's a new, higher level of organization. It's what happens when that web of constraints gets so interconnected that it basically closes in on itself at a global scale. This system as a whole starts managing its own internal workings. It becomes both the operator and the machine all at once.
Probably the best way to think about this is like a phase transition in physics. You've got a bunch of water molecules just bouncing around randomly. As you cool them down, they don't just get a little slower. At a critical point, 0 degrees Celsius, bam, they suddenly lock into this highly organized, globally integrated structure we call ice. The theory is that consciousness is like that, a phase transition in the brain's organization.
And once that transition happens, you get this new, globally integrated system. And what does that give you? Well, it gives you all the hallmarks of consciousness. Suddenly, information from all over can be brought together. You have a huge variety of different possible states. You gain the ability to direct your own attention. And crucially, you get this unified sense of self that persists through time, connecting past, present, and future.
So, what's the view from the top? After climbing this whole ladder, where are we? Let's bring it all together.
This timeline really sums up the whole journey, doesn't it? You start with simple real-time adaptation. Then you get memory, where the past starts to shape the present. Then you get cognition, using those memories to act intelligently. And finally, you get consciousness, where the whole system folds in on itself and becomes self-aware. It's one continuous story of organization getting deeper and deeper. So at the end of the day, the really crucial takeaway is this. Mind isn't some extra mysterious ingredient that gets sprinkled onto matter. Instead, mind is a spectrum of organizational complexity. It's a property that just naturally emerges when systems get better and better at this whole self-maintenance game, from the humblest bacterium all the way up to the human brain. And that leaves us with one final and pretty provocative question. This theory doesn't really care what the system is made of. It's all about the pattern, the organization. So if consciousness is just a particular kind of organizational dance, well, could we, at least in principle, teach that dance to something that isn't biological? And that's a question that brings biology, AI, and philosophy all crashing together, and one this framework really forces us to think about.